Okay, are there other questions? So we have some question about significance testing. If Michelle, if you don't mind, if there's nobody else that's wondering about that, maybe you can read that. Feel free to get in touch because that's important that you guys understand that.
Mm-hmm.
Uh, maybe we can discuss a little bit more at the end of the session if you want.
Okay.
Okay. Then we had some question about the t-tests. And what other questions do you guys have? And Michelle, maybe as we discuss t-tests, then maybe some of those questions will clarify as well.
Yeah, I think I'm still a little bit behind other people, but I'm catching up.
Okay, cool. That's okay. That's okay. Right. Sometimes it's good to hear, and I appreciate for those of you who go ahead and sometimes you find questions or things are could be explained better. So that's always good to let me know, and I keep switching things around a little bit, adding things so that trying to benefit from the feedback that you guys give me. So that's I always appreciate that. So if there's no other questions, what I suggest is that I jump in with the t-test, and maybe at a pretty high level. If that's Grace, would that be all right? Do you think that would help with your question? And what I'd like for you guys to do is, if I'm too general, then let me know. Okay, then I'll become more specific. How does that sound?
It sounds good to me. I'm just following along.
All right. So, so in the t-test, right? You guys should see my slides now. Do you see that?
Yes.
So what do we do in the t-test? What's the basic idea?
I forgot to turn on mute.
Right. If you Grace, you've been talking about the confidence interval, 95% confidence interval, right?
Yeah.
Have you guys understood the idea of the central limit theorem, right? The sampling distribution of means, right? So basically that means we have a population, but that population we don't really know, right? We can't go ask everybody. So we draw a sample. And the sample has, let's say we're looking at a test score of a class, right? We want to know, hey, how is the school district doing? We're pulling a sample out of a class. We get a value. Let's say we're going to keep it simple. We say they scored 500 points. Okay. And now let's make it better with the IQ test, right? We say the average IQ is 100. We are wondering, we're going to Flint, Michigan. Have you guys heard about the water there? How the water was really polluted with lead and all kinds of stuff from the auto industry. And one of the things was that kids that would drink this water with lead poisoning in general, it leads to lower IQs, attention deficit, etc. Right? So let's say that we're taking a group of Flint students and we want to see is their IQ lower than average, right? So it might be let's say 100 is our average, and now we're taking a sample, and as you know that the sample, if we drew 10 samples, all of them would have a little bit different averages, right? Even if they're totally normal, some of them might have a sample average of 99, others 98, and there's maybe one at 102, right? It would fluctuate a little bit, right? And so in module 3, you guys learned about the 95% confidence interval, right? You said, okay, we just drew one sample, but based on that, we kind of figure out what's the range, what's the 95% confidence interval within which we expect most of our samples to be in, to lay within, okay? And now in the t-test, we use this concept to, for example, compare groups to each other, that would be the independent samples t-test. Or we could compare a group to a certain value, right? We could say, okay, the average is 100. Now we drew that sample, and now we're comparing it. Is that sample different from 100 or not? Right? But what we're doing now is not just draw a sample and let's say it's 98 and then say, oh, 98 is lower than 100, right? We realize that 98 has a certain error margin with it, right? So now we try to see, is it significantly different than the 100? Right? So that's kind of the idea between the t-test, or in general, that each mean has an error margin associated with it. So now if I point you to the slide, let's say red is that Flint sample, right? And then the blue one, let's say, is a sample, not too far away, but where they have really great fresh spring water and there's no lead contamination. And now we want to figure out, is there a difference between these two samples or not? Right? If you look at the case A, right, we could say, well, there's very little overlap between these two distributions, right? Between these two sample distributions here. Right? However, if you looked at the case B, we would see a huge overlap, right? So, and note that the actual means, right, where the black line is at, the black vertical line, that mean is exactly the same. The difference between those means is exactly the same. Can you guys see that? What is different?
It looks like the standard error of margin's different.
Right, right. Where is it smaller, on the top or on the bottom?
It's on the top, there's a smaller margin of error allowed.
Exactly. Right? So in the top, there's a smaller margin of error. And now if we would plug in these values into the T formula, we would likely get a statistically significant difference.
Yeah.
If we plug the same, the values from B, which is the same mean difference, but different standard errors, then likely here we would not get a statistically significant difference. Is everybody good so far?
Yeah, I'm good so far, but to be honest, when I look at B, I mean, just visually, it almost looks like there is too much of a difference. Like, I guess it depends on what, like, what's allowed, for the confidence level.
Exactly. So if you go to the next slide, maybe that one is a better example, that when you look at the middle with the high variability, right, it's really a big overlap of these.
Yeah, I see.
Right?
I see, yeah.
So what the t-test does is basically three measures here. Say the difference between the means of the groups. Then we look at the sample size and the variability of the data. The sample size and variability of the data gives us the standard error. Right, that's what we use to calculate standard error. And then we get a critical t-value. And then we figure out, here it is. If that t-value is close to 0, that would mean there's no statistically significant difference, right? And you could see as we go towards the borders of this distribution, right, the t-values are getting bigger, and it becomes increasingly unlikely to get such a big t-value if your null hypothesis is true, right? Sometimes in reality there's no difference between the groups, but because of some weird situation, we have one group that's really high, the other one that's really low, and then we get a big t-value, and it's highly unlikely that we get such a t-value, but it can happen. Okay, that's why we have this bell-shaped distribution. Now, the whole logic of hypothesis testing is to say we assume the null hypothesis, and then we look at what kind of evidence do we find in reality. And if the evidence is highly unlikely to be true, if there is actually no difference, then we change our mind. Then we reject the null hypothesis, right? Then we say, hey, we found such a big difference. You know what? If there weren't any difference in reality, we probably wouldn't find that. So we reject the null and we assume there is a difference between the groups. Everybody okay so far?
Well, just to be clear, it kind of seems like we always set it up to, like, as if the alternate is the one we actually want. It's almost like we set it up that way.
Okay, good point. So it's always set up like a coin, right? You always have a null, and then you have the alternative hypothesis. Which one you actually endorse doesn't really matter. Well, it matters, but it always comes in pairs. So the null we always have.
Yeah, so it seems like it doesn't matter, but when I read through the book, it seems like there's like a like this pattern of setting up the null as if like probably that's the one we're going to reject. I mean, I kind of see a pattern like that.
Okay, yeah. So we try to reject the null. That's our thing. We
Okay.
never, and this is really important for you guys to remember. We can never really prove anything.
Yeah.
We can only find support.
Okay.
And we try to reject the null. We try to find a difference where like, it's kind of like, imagine you're saying, hey, I believe there's only white swans, and you're trying to find a black swan that proves that suggest, right? If you find 1,000 white swans, you haven't really proven that there's no black swans, right? You just have
Right.
more and more support of white swans.
Yeah.
Okay. So far, so good. And there's also that you can also look. I don't know. Have you guys looked at the videos yet about the t-tests? So I kind of talk about that as well, right? So this is really kind of repeating the information. Here it's important that for each sample size you have a different distribution, right? That's why those critical t-values change, right? That's why you either look them up in the table or you get them from the software, right? Either way. And then here, how you calculate it. Let me go. Here. All right. So here again, these are basically the three options that you have, right? Note that H null, the null hypothesis, is always the same. What changes is if we have actually a directional hypothesis where we say it goes one or the other way, or we don't know. One of them is higher than the other, right? In this instance here, we would say, again, assuming that mu is for the kids in Flint, we would say we assume that they have lower IQ than the other group because they've been drinking this polluted water all their lives, right? So this lead has affected their biology and has lowered their IQs. So we would have a directional hypothesis. On the other hand, the guys that say, hey, the city of Flint, right, that says here, drink this water, you'll be fine. They would probably say there's no difference. They say, hey, those kids might be higher or lower. We have no reason to believe that they should be lower. They also don't have any reason to believe that they should be higher, right? But they would go in the middle.
Can I ask a question on that slide that we just passed?
Sure. This one here? Or
yeah. For example, in exercise 5.1, 1 t-test worksheet.
Yep.
The significant level of the level of significance, the 0.5, 0.05, 0.01. How do I find that in that worksheet? Because I didn't see anything that gave me the significance level. Was I supposed to just randomly pick one, like, and then do the rest of the calculations for the critical t-value?
Can you guys still see my full slide? No, now you see everything, right?
Well,
Yeah, we see everything.
Yeah, I'm trying to go look at the worksheet. Usually, if I don't say anything else, it's the 5% significance
Okay.
level. Okay.
Okay, that's what I was thinking.
Okay, but thank you for bringing that up, because that's information that that I should put in there, that so that you know.
And then when I think the other question that I'm still struggling on is, after you find the t-value, am I saying that right?
The t-value, yes.
When you get your significance, okay, then you subtract it to find your tails, or the, God, these vocabulary words are just driving me insane. The 2 parts of the, I feel
I'm
like
with
an
you,
idiot.
Grace. I'm right there with you.
Critical. Oh, Jesus. Okay, the T critical areas and the T value. There's a formula where you subtract 1 minus something, and then you do 1 plus something. T. There, I'm lost on that part. That part I'm getting confused also. I feel like I'm just so not with this.
I'm not sure which one you're talking. The n-1.
Okay, there's a part where it's a formula, and I don't have it on me. I don't remember. I saw it in the book. You're finding on the, you find your t-value, I think, and you're subtracting it from one side. You subtract, and then the other side you add to do the right and the left side. I'm just going to talk like an idiot. I'm so sorry, but I don't remember what is that part? I need to find the critical and the t-value. Once I've found my significance level and I find my t-value, then what do? I don't know what I do next after that.
Oh, okay. So
Because I need to, yeah, I'm lost right there.
okay, let's do an example.
I need to learn these words.
I gotta make myself some flashcards for exactly the same reason.
I feel like these vocabulary words are just jumbled in my brain already. I can't get them all straight anymore.
When I'm doing my homework, I have all these little Post-it notes out all over to remind myself what all the symbols are and the different formulas.
I have worksheets of pages of formulas. Me too. I'm all that.
I'm glad it's not just me.
No, girl, I'm dying. Okay, I have my high schooler here sitting with me listening, so if I get something wrong, she's going to back me up later on.
Yeah, tell her to pay attention.
Okay, honey, pay attention.
Okay, can you guys see my screen?
Yes.
All right. So what we do is, with the t-test, independent t-test, dependent t-test, or one sample t-test, the result what we're getting is a t-value. Okay. And that basically, that t-value is our measure of, basically our summary of how big that difference is, right? Independent of what the mean is, what the standard deviation is, etc. We just want to know how far away is this t-value from 0. Right? If the t-value will be exactly 0, that would tell us that there is exactly a 0 difference between those groups. Right? And now what we do is we define the T critical, those boundaries. And once we pass those boundaries, then we talk about rejecting our null hypothesis. Okay, so usually, let's say if we talk about the 5% significance level, we say that the T value, the statistic that we calculate, has to be outside of this white area to be 95%, right? In this case here, if we have gray areas on either side, we take that 5% and split it in two. We put 2.5 on one side and 2.5% on the other side. Okay, that's the same thing as, imagine what we talked about when we did the normal distribution, right? We had 2.5% values were very small, the other 2.5% were very big. Right here it is, on the left side would have negative T values, and on the right side we would have positive T values. Really, it doesn't matter because it just depends which group we had first, right? If we put the Flint kids minus the other kids, right, we might get a negative T value. If we put the other kids first and then the Flint kids, we might get a positive T value. Right? It just depends which group you put first. Right?
So am I comparing when I do my t-test calculation, am I comparing that number with my T value with my significance?
Okay. Let me really go through an example.
So when I do that t-test, am I comparing this number with something?
Yes. So
okay.
let me go through this here, right? We have this example with these two groups, right? We have our T formula. We plug in our numbers, right? We have on the top, we calculate the mean difference. And on the bottom, we calculate basically the standard errors of each of these groups, right? And then when we compare the difference compared to the standard deviation sample size, then we get that 1.99 T value, right? And now that by itself doesn't really tell us a whole lot. It just tells us if it was really close to zero, you without even looking, you know, there's not going to be a significant difference, right? But now what you do is you look at this 1.99, and now we have to look up what's the critical T value. Okay, let me scoot back here for a second, right? Let's say that 1.99 is in this pink, it's this pink cross here. Okay. What our question is now is that already out here in this gray area, or is it still in this white area? Right? If you had the T value that's red, right, here, you're always in the white area. The conclusion would be there's no significant difference, right? We go with the null hypothesis. Then you have where the T critical is at. This you would look up in the table. And now our question, right, basically is the T value that we calculate, is that bigger than this critical T value? If it is, and we're in this gray area, then we reject the null.